Hello, good evening, and welcome to the TNT show. I'm John Drummond, and I'm your host for the next 60, and I guarantee you, exciting minutes. If you enjoyed last week's show with Marcus Chown, and many of you did, then you'll find this is a very helpful continuation of much of what he was saying, because we have another scientist on the show. Tell you all about that in a second. But you know, it's been another great day for British democracy. Today, Tory MPs have voted in the last couple of hours or so to approve corruption and sleaze. Officially, corruption and sleaze have been approved in the workings of the House of Commons. Now, this effectively ends the rule of law with regard to their affairs. Now, this is an English tradition dating back to 1695, and it's now been ended. Corruption is now officially approved in the House of Commons. MPs can now freely be the hired hands of corporate lobbyists with impunity. MPs who voted to jump the rules, 250. MPs, those perhaps with a tinge of conscience, voting to retain the rules, 232, which means that was a government majority for corruption of 18. Rules? Well, apparently rules are for other people, not for MPs. It's a shameful day, but that's British democracy for you. Thanks for joining us this evening. Tonight, we are talking to COP26 activist and scientist Graeme Eddolls. We'll be discussing his views on COP26, what he thinks of Brexit and physics, and why he might favour independence, and so much more besides. And he's taking your questions live. Details are on the What's On guide at whatsonguide.scot. Now, as you know, TNT stands for The Nation Talks, so in many respects, this is your show. We're live and we're free, so no licence, no problem. Now to our guest tonight. The Nation talks to Graeme Eddolls. Graeme, how are you?
I'm very well, thank you, John. Been out around the city, doing a lot of cycling on the cargo bike around the barricades, police and mess that is COP26 around Glasgow at the moment. I was doing some sort of restocking of food and whatnot for our offices, listening to sort of stuff on my phone and getting lots of messages coming in about lots of direct action taking place and sort of demonstrations throughout the city. I heard that we've got some demonstrations outside the city chambers at the moment. We've got people who are unfortunately being kettled by the police under the Kingston Bridge currently. We've got demonstrations taking place at Kelvin Park. And I think we've even got a squat that's been set up to house people just in the Tradeston area of Glasgow at the moment. So there's, I'm very busy, but very happy to be on the show.
Well, it's a great pleasure to have you. What is planned for the next period of time until COP26 officially ends?
So the COP26 Coalition, who I work with and have done for the last 2 years, some of the biggest events we've got coming up are this Friday and Saturday. So separate from the coalition, organised by our fantastic Fridays for Future activists in Scotland and Glasgow, we have the youth strikes. So they're taking place on the 5th of November. They're at 11 o'clock at Kelvin Grove Park. You'll have Greta Thunberg there and all the Fridays for Future activists. You'll have the trade unions there, because some of you maybe saw on Twitter that she invited the local Glasgow trade unions to get involved, and they extend the invitation to everyone of all ages to join the youth strikes on Friday. And then following that, on the 6th of November, the COP26 Coalition have organised a global day of action. So there's over 190 events around the world, and the biggest one we're hoping will be centred on Glasgow. So we're asking people to assemble at Kelvin Grove Park at 11:30 a.m. and we will march down to the COP venue together, and then we'll march through George Square and we'll have a finishing rally in Glasgow Green at 3 p.m.
That's fantastic. Well, I do hope as many people as possible who can make it turn up. And I think it's going to be covered on Indie Live too. So those of you who can't make it at least can join in the process from a distance if you need to. And I would encourage you all to tune in if you can't actually be there yourself. But as Graeme pointed out, it's better if you can make it, to be there, because it sounds very comprehensive. It sounds like it's going to be a real good day. What's the weather like schedule for Saturday? Is it going to be good or what?
Last time I looked, which is, to be fair, a few days ago, it was like dry weather on Friday and then wet on the Saturday. But I'm sure that won't put a lot of local Glaswegians off. We want as many Glaswegians in particular as part of this march, whether they're in support of the COP and the marching for the climate crisis, or whether they are actually angry at the fact that the COP has been imposed on Glasgow. We welcome everyone along. There's lots and lots of different blocks to join. We've got anti-racist and migrant justice blocks. Organising the Glasgow Communities blocks, which is just for local Glaswegians to take part and march alongside some community organisations. And we've got our independence block. So that's covering everything from All Under One Banner and the Radical Independence campaign. So people are more than welcome to join into whatever block they feel most welcome in.
Good. That sounds super. Tell us a little bit about yourself, Graeme. I mean, you once worked in defence, and you're also a STEM ambassador. What was all that about? What was your defence work? Can you talk about it, or is it a secret, state secret?
No, not quite. So yeah, I used to work for a private defence company. I used to work out opposite Faslane, a place called Rosneath on the Coolport Peninsula, and I worked there as a sort of civilian scientist and engineer, working basically looking at measuring electromagnetic signatures from Royal Navy ships and submarines. I specialised in looking at minesweepers in particular, and the work that I did was to basically try and protect ships and submarines from setting off sea mines under the water, and also allowing submarines to operate under the water undetected from aircraft that would fly backwards and forwards and hunt for them.
How do you do that without getting terribly technical and losing everyone? I mean, an aircraft flies obviously over the surface of the water, and what does it use to try and detect an underwater object? Does it use sonar?
So they use these little things called MAD detectors, magnetic anomaly detectors. So it looks basically at the Earth's magnetic field. It flies backwards and forwards over the sea, and it looks for a tiny change in Earth's magnetic field. And the only way you generally get a tiny change is if there's a big lump of metal under the water, which is sort of concentrating that field. So that big lump of metal under the water is going to be a submarine. So that's what it looks for when it's flying backwards and forwards trying to track them.
That's fascinating, absolutely fascinating. Tell us about STEM. You're a STEM ambassador. Are you still a STEM ambassador?
Yep. I've been a STEM ambassador for 11 years now. So STEM, most people have come across it. It's science, technology, engineering, and maths. It's just an acronym of that. And it's a government national program. So it covers everyone from, for example, all your BT engineers. When they join up as an engineer in BT, you automatically get trained as a STEM ambassador. So people who just generally volunteer. So if people who work in science, technology, engineering, and maths are passionate about it and you want other people to get involved and join in, if you want to encourage the next generation of kids to take up STEM subjects, then that's what we do, because we had a very big national shortage for a long time of people not taking up science, technology, engineering, and maths. And thankfully, we are seeing that trend really reverse now and seeing a massive upward trend in it being the most popular subjects in schools and colleges and universities.
And was there a gender split? I mean, did this fall in people being involved? Was that more particularly amongst girls or boys, or was it pretty much across the board?
Yeah, there is still a massive gender split in sciences, particularly in physics and maths. That they are some of the worst subjects for that. When I started, I went to University of Glasgow in 2010 to do a degree in astrophysics. Interestingly, the astronomy side was split about 50% girls, 50% boys. That physics was very much sort of 80% men, 20% women, and I think there's still an issue, as I understand it, it's called the leaky pipeline, whereby we may get more girls now into STEM at higher levels, but they don't stay on. There's not support there. So we still don't see high in academic positions like professors well represented amongst women. It predominantly still men. So yeah, that's still a major issue in STEM at the moment.
Is anything being done to address that?
There's a lot of work going on. I think there is good work going on from the Open University looking at barriers into physics, the way questions are worded to bias towards men to make it easier to answer, or it's more amenable for men to answer questions the way that they're posed. Support structures in place to properly support things like maternity leave, because women are predominantly punished for those kind of things. Pay gaps as well. It's an issue across all sectors, and STEM is no different. Women are still traditionally paid less than men. So there's probably a whole lot more work which needs to be done, but there are some initiatives in play that I understand at the moment.
Well, that's good. That's good. Just reverting back to COP26, we've had a question from Dave McBeath. He's saying, obviously, he's concerned about this new variant of COVID that is supposed to be rampant in the UK at the moment. And he's asking, will that not have a detrimental effect on the numbers on the march?
So that's an interesting question from 2 points. One, in terms of health and safety for people on the march, we are going above and beyond the current Scottish Government guidance. So we are asking everyone who comes to our march to take a lateral flow test before they arrive. We are asking everyone to continue to wear a mask outside at all times and to maintain 1 meter distance. So that's for safety of people here. One thing we do not want is to bring new variants into Glasgow or into Scotland. And on that point, that's something that the UK government has done to specifically exclude activists from the global south and elsewhere outside the UK, is they've used COVID as an excuse to make sure their voices can't be represented here in Glasgow, that they can't speak up, the people who are experiencing the climate crisis. So it's being used very much as a tool to exclude people from this conference. And it's why we believe that COP26 is probably the most unequal COP to have ever taken place so far.
So you would encourage people to come along and participate, and well, that sounds good to me. Now, I want to ask you about U of Gravity. What is that?
So specifically, U of Gravity is the Twitter handle for our research group, which I'm part of. So I'm almost finished my PhD at the University of Glasgow. I went back after my 3 years in the defence sector, and I'm part of the research group called the Institute for Gravitational Research. And what we do at the University of Glasgow, there in the School of Physics and Astronomy, is we work both on data analysis, which is looking at data from certain types of space detectors that look for these things called gravitational waves. And we have another half of the group which works in experimental physics, like myself, working to build new types of these gravitational wave detectors.
I mean, Marcus Chown touched upon this last week, but I gather you have a particular insight, because I gather that Einstein forecast the existence of such, but it took quite some time before the actuality to be better understood. What was the story there? Tell us the story there.
Indeed. So I'm not a theorist, and I'm not very good at maths, believe it or not. As someone who does a physics PhD, my dad was a maths teacher, so I should probably be a lot better. But when you work in a lot of mathematical theories and physics, sometimes things fall out of them. The maths tells you something. There's a funny factor. There's a funny thing left over. There's something in the maths that sometimes says, "Oh, what is this? What is this oddity?" And Einstein discovered, when he developed his theory of general relativity, that according to this theory, that space-time should be able to be warped. And if you can warp and bend space-time, that you could wobble it, you could send out waves through space and time itself. So he theorized that you should have these gravitational waves. The math says that if you have an awful lot of mass, lots and lots of material in space that's really, really, really dense, and it's moving really quickly, we're talking half the speed of light, then it should be enough to kick the fabric of space-time itself, to send a wobble or a ripple through it. And he predicted that over 100 years ago. The problem is, he said, the amount that it wobbles space and time itself is so tiny. On Earth, it's about 1,000th the diameter of a proton. So 1,000 times smaller than the inside of an atom is how much it wobbles it. He says we'd never be able to detect it. It's just not possible to build a detector. But it took 101 years thereabouts, almost 100 years of research and development, scientists working together collaboratively to build these detectors so that we were able to announce in 2016, I believe, 2015, I believe, I always get those years mixed up, to the public that we had actually detected gravitational waves for the first time. And that detection won the Nobel Prize in Physics in 2017.
Well, it's fantastic. And I gather Glasgow had a major role in this. There was collaboration across the world, but I gather Glasgow had a special place in that work. What was that?
Absolutely. So a lot of the work at Glasgow was done by the late Professor Ron Drever and current Professor Sir James Huff. They worked on a different type of detector called an aluminium bar detector, which was helped develop by, I think it was American physicist Joseph Weber. And it worked on the principle that as these waves pass by Earth and pass through Earth, that they would vibrate this aluminium bar, and it would kind of resonate, and we'd be able to pick that resonance up and measure it. Unfortunately, that was never shown to be the case when it was peer reviewed and the data came in. So we moved to a new type of detector, which is basically called an interferometer, is what physicists call it. But it's called that because it interferes light with itself. So we call it an interferometer. And all we do is we shine two beams of light over a very long distance, 4 kilometers, and we reflect them off mirrors, and the light comes back. And we look at how the light is changed when it comes back. 99% of the time, nothing happens because there's no gravitational waves passing by, so the light is exactly the same. But when that wobble passes through Earth and stretches and squashes the space-time ever so slightly, the light changes in those arms of light as they go out and they reflect and they come back. And we look for that change in the light. We compare the light from one beam to another. And when we see that change, then we can say we've detected a gravitational wave. The problem is, because our detectors have to be so sensitive to detect these tiny changes, they are very sensitive that they pick anything up. You know, if you were to knock the detector, then all of a sudden the light's going to change and you're going to say, oh, I've discovered a gravitational wave. And in actual fact, you haven't. It's just because you've knocked the detector, the mirrors move too much. So a lot of the work Glasgow did was in isolating these mirrors from their outside environment. So one of the ways you can do that is you don't just stick the mirror in the ground, like on a pole, or set it on a surface like a table, because the ground is always moving very slowly and very small amounts, but the ground is constantly shifting. So we need to isolate it from that. So we put it on these very special platforms, which keep everything nice and still. And then what you do is you hang it from a pendulum, because if the ground is vibrating at a certain amount, then if you can think of a yo-yo, if you hold onto a yo-yo and you have the string extended and you shake it very quickly, the yo-yo will stay very, very still. And that's what we want to do. So in reality, these mirrors are actually a pendulum on a pendulum on a pendulum on a pendulum. It's 4 pendula all together to make sure these mirrors stay very, very still. And Glasgow helped develop the very last stage of those mirrors. So we hang these mirrors from glass fibers, and these glass fibers were developed at the University of Glasgow. Professor Ray Weiss, one of the Nobel Prize winners, actually mentions it in his Nobel Prize winning speech, which you can see on YouTube, and he mentions Glasgow's contribution to the suspensions, as we call them, the things that hold the very last mirror where we shine our laser off of, and how instrumental that was in detecting these gravitational waves.
Fascinating. So these gravitational waves clearly are out there, they're measurable. It's difficult to do so, but they're there. What can we learn from that? I mean, a lot of people watching and listening will be thinking, well, that's terrifically interesting. And people often ask me this question when I talk about physics. They say, what's the practical application, John? So I can't not ask you that question because everyone else is thinking it.
It's the most valid question to ask. A lot of people are like, what's the point? And fair, it's your tax money that's paying for this, and we're spending billions of pounds on it. And people are like, well, what is the point? So initially, there is a lot of great science. For the scientists, the science you can get out of this, it lets us, from a philosophical point of view, it lets us understand the universe better. It lets us understand about black holes, let us understand about how the universe is expanding. It might help us answer the question why the universe is expanding, because we still don't quite understand that. So a lot of it is this, what we call very blue skies, stuff that doesn't have a lot of application to everyday life. But as is always the case, especially with large-scale physics experiments like the Large Hadron Collider, there's always technology which falls out of it that impacts our day-to-day lives. The World Wide Web came out the back of the Large Hadron Collider. They had to figure out, how are we going to move all this particle physics data around different collaborations around the world? They developed the internet, which we all enjoy today. For the LIGO detectors, so LIGO stands for Laser Interferometer Gravitational Wave Observatory, which is a very long acronym for which we scientists love to use. So there's two detectors in America, and they are the ones that were part of the Nobel Prize winning detection. The science that comes at the back of them that can impact our daily lives is quite astounding. So one way that has an impact on our lives, or will soon, hopefully, is we are working on miniaturizing ways of detecting gravity, so that rather than having something the size of a room or the size of a van to look at changes in Earth's gravity, we can have something the size of your mobile phone that's very portable. And you think, well, why would you want to measure the change in Earth's gravity? What's the point in that? It's really, really useful for volcanic eruption detection. Rather than waiting for earthquakes and tremors on a mountain or on a volcano and evacuating people where it might be too late, what you can do is you can start to measure the gravity of the volcano. And as magma starts to build up under the volcano, the gravitational pull will start to increase because there's more and more mass underneath. So it allows us to evacuate people well in advance of any potential eruption. Another fantastic spin-off that comes from the gravitational wave detectors themselves, which I think is really great, and is also work done in Glasgow, is there's someone called Professor Stuart Reid, who's head of biomedical engineering at the University of Strathclyde. And they work with us on the optical coatings on these mirrors. So I said we shine light and it reflects off the mirrors and it comes back. We need, I think it's 99.9999% of that light to come back off the edge of that mirror. So a lot of work goes into the very, very, very special coatings which sit on the surface of these mirrors. And the technology they use to coat these mirrors is called nano-kicking. I don't quite understand how that works, but someone discovered that if you apply this nano-kicking technology to stem cells, you can actually help stem cells grow an awful lot faster. Because one of the issues is if you want to use stem cells to, let's say, grow a hand in a lab, then if you start to grow the cells in the middle and you start to grow the cells further and further out, by the time these cells develop further out, then the cells in the middle have died. So you need to sort of really grow. If you want to build centimeter scale things out of tissue and stem cells, you need to promote the growth. So the idea is that the technology that can come out the back of this with the nano-kicking technologies, you could potentially have in the future the ability to regrow limbs in medical advances, meaning you could regrow limbs using your own stem cells, so your body wouldn't reject your arm or your new heart or whatever it is, rather than having to rely on donations or prosthetics. And I think that's quite a fantastic thing to have actually come out the back of the LIGO work. So
it is fascinating because apart from anything else, it means that people could live forever. If you think about it, I mean, if for example, you could grow an arm or a leg, you could presumably grow a new heart. I mean, or new organs of any kind, I assume. Fascinating, absolutely fascinating. I want to do a couple of questions, if I may, and perhaps we can come back to this in a second, Graeme. Charles Smith is asking if you have a view on participating in developing energy via nuclear fission, not nuclear fusion, sorry, not nuclear fission. What's your view on that?
So, I mean, that's an interesting question because it takes the two. I'm not a climate scientist and I'm not an energy scientist. I will caveat that, but it takes the two issues of energy production and the climate crisis and the science. And one of the things I think we've got to be very careful is not trying to techno fix our way out of this crisis that we're in. Science can only do so much. And I think we've got to be careful about the idea of sciencing our way out of the climate crisis. I think for the purposes of pure research and blue skies, I would always say, yes, we should be looking into fusion research. But what we shouldn't do is put all our eggs into that basket, and we shouldn't rely on it to save us, so to speak. And again, there will be hopefully fantastic technologies and things that we never even thought about that come out of the back of research into nuclear fusion. I think it's a fantastically exciting field of physics to work in. But I think in terms of solving the energy problems we have right now, it's not a solution in that sense. We don't have time. It's always a bit of a running joke in the physics community. I'm sure you've all heard it, that nuclear fusion is only 10 years away. And they said that 10 years ago and 20 years ago and 30 years ago. But that's not to say the research shouldn't continue. Of course it should. We need to make sure that governments fund research like that, because there's a lot of stuff that comes off the back of these technologies that even the scientists didn't predict. So it's definitely something that should still be pursued.
Good point. Jim McIntyre, his question is, and this is very specifically about what you've just been talking about, what would the length of the arms of the detector need to be to detect the after wobble of the Big Bang?
Well, I'll tell you, I don't know is the first answer to that. I have no idea what. So there's an interesting question, because there's different types of gravitational waves that we try and detect. So the ones that we've detected so far basically come from black holes orbiting around one another, just like the planet, like Earth orbits around the sun. And black holes orbit around one another, and they get faster and faster and faster, and they orbit around and they get quicker and quicker until they combine into one big black hole. And as they do that, they send out these ripples. So you get these kind of binary black hole events that we call them, and the sort of signals go faster and faster and faster, and then they stop. Another one we're looking for is continuous wave gravitational waves. So basically that's if you've got like a pulsar, which is or a neutron star, a very, very, very dense star, which has like what we call a mountain, but it's a tiny little lump in it off the surface. And as that spins around, as the neutron star turns on its axis very quickly, it sends out these continuous waves. We haven't detected them yet. But another type that we are trying to detect as well is gravitational waves that should have emanated from the start of the Big Bang, because you have a lot of mass moving very quickly. So you would expect to be able to detect that in the background. So that is something scientists are currently looking at. And that's something someone who's an astronomer who know an awful lot more than me, they're working on at the moment to try and see if we can find that in the data to look for that Big Bang detection.
I mean, this is all, for me anyway, and I hope for others, absolutely fascinating. Because first of all, it talks about the very origin of us in a very remote way, as it were, because we came very late in the day, I suspect, as a human species. But we wouldn't be here today if all of this hadn't gone before in some way, shape, or form. And it also leads to questions about if it's possible for space-time, that gravitational field to change. Is there a possibility that will produce wormholes? Is that what a wormhole is? A peculiarity in space-time?
So, I mean, when I can talk more in the context of black holes. So black holes, we say, are a bit like a tear in the fabric of space-time. There's a really good example we always use when we do a lot of STEM outreach with people of all ages. Is we kind of like to describe space-time as, imagine a rubber sheet on the surface, and if there's no mass, there's no planets, no stars, the rubber sheet is flat. As soon as I put planet Earth, which is, let's say, a marble, onto that sheet into space-time, then you'll see that it bends space and time itself a little bit. And if I put something much larger, like a big lead mass, which let's say represents the sun, then it will bend space-time around it even more. If you were to bend space-time so much to pull the bottom of that sheet so hard that you actually create a hole in it, that you rip a hole in it, then that's kind of how we describe a bit like a black hole. What goes on beyond the inside of a black hole, we don't really know. Gravitational waves actually allow us to potentially probe the inside of a black hole, which is really interesting. It's a bit of a cheesy phrase we like to say, but it is a new window on the universe. 99% of astronomy you've ever engaged with relies on electromagnetic radiation, be it visible, so the way we all see, or infrared light or radio waves, whereas we actually image effectively using gravity. And because black holes only ever suck in light, then you can't get any information back out from a black hole past what we call the event horizon, the very edge of it. Whereas when we look at the sort of final death throes of these two black holes as they come together, there's potential to get information out as to how the event horizons, the edge of these black holes come together and merge to allow us to peer inside the black hole and what sort of goes on in there which is hopefully quite interesting as we get the data out.
Fascinating. Mandy Garden is asking, why are some of the biggest telescopes being closed recently?
I don't know. Yeah, I wasn't aware of that being the case, and I don't know in what context. I don't tend to work too much with optical or any kind of like standard electromagnetic astronomy. We do work with electromagnetic astronomers all the time. It was actually one of the things that vindicated our proof of gravitational waves, because the initial detection was met by a lot of skeptics in the scientific community. And there was a few people who, and that's healthy skepticism, who said, yeah, we don't believe you detected it. We think it's noise in your data. And the problem is, if we say we detected black holes, we can't really independently verify it, because if you point your telescope at the sky, you're not going to see much. It's dark. What then happened is we made a detection in 2017, which was two neutron stars smashing into each other. They sent out gravitational waves. When two neutron stars smash into each other, they produce an explosion that you can see. It's called a kilonova, a little bit smaller than a supernova, so it's called a kilonova. So what we did, and what we do to this day, is when we make a detection like that, we tell the astronomical community around the world, look over there right now, point your telescopes over there. And when they did that in 2017, they saw a kilonova, which kind of vindicated our detection. So we work, we call it multi-messenger astronomy now, and we work with all the sort of more normal astronomical telescopes to try and get as much data out of these collisions in space as possible to learn the science behind them. It actually helped us develop our understanding of how things like gold and platinum are produced in the universe. So if you're wearing a gold ring right now, there's every chance that gold was produced by two neutron stars smashing into each other, which I think is pretty cool. I can't answer specifically about biggest telescopes being closed. I don't know anything about that.
Maybe Mandy will get back to us and give us an example of what she means. But that's fascinating. So people wearing a gold ring, that's stardust. But we're all stardust, aren't we?
Yes, very much so. We are.
You and I and everyone watching and listening to it, we're all stardust, aren't we?
Yeah, we're just made of the more boring elements generally. Pretty much everything below iron on the periodic table, don't ask me what element number that is, I can't remember, is normally produced in sort of stars like our sun. Anything above that, you'll notice in the periodic table, everything above iron is a lot rarer and a lot more expensive. There's less of it. And it's typically produced in much higher energy explosions like supernova and kilonova. So that's why elements above iron on the table tend to be a lot rarer. And that's why things like your gold and your platinum are so expensive, because they're in such small amounts throughout the universe and throughout the Earth.
Is it the case that, I was going to use the word observable, but the detectable universe that we're familiar with is in fact only a fraction of what's out there. And in fact, the majority of it is dark matter of some kind or nature, which we don't know anything about. Is that the case?
So this is the scary thing in physics. We've done what we do best, is we just call it dark matter and dark energy. And don't ask me what that means. And don't ask most physicists, because they don't know. It's a sort of term they've phrased. What happened was a lot of observations were taken of galaxies throughout the universe, and one thing that they noticed is that everything was moving away from everything else. And we thought, well, that's a bit odd. And what was worse is, as they did more and more measurements, they discovered that everything's accelerating away faster and faster and faster from everything else. And that doesn't make any sense, because the laws of physics say, well, if you have two masses in space, they should be attracted to one another. So what's driving everything away? So we call that we don't know. First off, scientists don't have a clue. So we call that dark energy, the thing that's driving things away from each other in the universe. And we can't explain that at the moment. And dark matter is another one whereby we image galaxies, and we, through kind of very sophisticated techniques like looking at the speeds of how stars move around the edge of a galactic disk and things like that, we can estimate the mass of the galaxy, how much matter is there. But when we look at data in terms of particularly looking at speeds and things whizzing around the edge of a galaxy, the calculations say that there should be so much more matter there than you can actually visibly see. If you look at the stars and count them and add it all up, it doesn't make any sense. And there's a lot of missing matter. So we call that dark matter, because we don't know what it is. But yes, in terms of everything you see, everything you touch, everything in the universe that is tangible, is visible, is detectable, that makes up what we think in physics about 4% of the universe.
Wow.
Yeah. So that's everything. And that's everything that we know of in the standard model of physics. So even stuff you can't see. So your radio waves and all the emissions that, you know, our eyes don't detect, but that we can detect with our detectors, all of that is included in that 4%. So there's 96% of the universe we don't actually know about, which is why we need more scientists to look into it, basically.
I mean, that's extraordinary. And the other notion that's even more mind-blowing than that is that some people contend that this isn't the only universe. There are multi-universes.
Yes, there is the multiverse theory. And it's one of those questions is how do you prove that? It's very difficult. Is it provable? It almost gets more into the branch of metaphysics and philosophy as to how you would go about detecting something external. You'd have to ask the question, is it possible? Is there a point to it if you just can't detect it? Because if you can detect it, then hang on a minute, does that not then become part of your universe by the very fact that you can detect it? So yes, there's all sorts of weird and wonderful hypotheses as to that. And parallel universes is one of my favorite. You know, everyone says in the parallel universe, you're the president, you know, of the US, or there's an independent Scotland in the European Union in the parallel universe right now. You never know. It's always fascinating to sort of think about these weird and wonderful scenarios.
But it is. I mean, it's just you know, it's mind blowing for most people who only have a minimal understanding of physics that only 4% of the universe is actually knowable, as it were, until some other technology comes along that enables us to somehow detect the bigger part of it, the much bigger part of it. It's extraordinary. A lot of people are going to ask this question. They'll be thinking about it just now, so I'm going to ask it. What was there before the Big Bang?
I have absolutely no idea. I have absolutely no idea. I mean, I've heard all sorts of weird and wonderful theories that the Big Bang repeats itself. I've heard that the Big Bang is just a tiny event in another larger universe. I have absolutely no idea. And I think that's very much an interesting question to ask yourself, or come up with weird and wonderful ideas as to what could possibly have existed before then, if at all.
So what is the scientific basis then for the Big Bang?
So, the scientific basis, we have a fairly good understanding as to how the universe developed from the Big Bang, not from obviously what happened before then. I mean, obviously the idea is that time effectively started with the Big Bang. So that's a very difficult concept to get your head around anyway, because if there wasn't time before the Big Bang, then, well, was there anything before the Big Bang if time doesn't exist? And you need time to define things, to have a timeline of things for events to happen, for a universe to exist. But immediately after the Big Bang, for about 300,000 years, we had this cosmic soup. There was a lot of heat in the universe. There was a lot of energy in the universe. All the atoms were stripped of we didn't have atoms really as we know them today. It was just a lot of particles whizzing around in this massive soup. And as that cooled down, eventually the very first atoms were starting to form, like hydrogen, because the electrons and the protons that make that up were whizzing around because they had all this energy. As they cooled down, they started to bind and they started to come together into the sort of universe, the very early universe as we know it today, where you got production of massive hydrogen and gas clouds, which then over time slowly started to collapse to create the very first stars. And we can actually see, people are like, well, is there any evidence for that 300,000 year old cosmic soup? And if we look back into the observable universe, you get this background radiation that came from that. We call it the cosmic microwave background radiation, the CMBR. So we have evidence to suggest that was the case. And because there was so much energy, and because the universe wasn't, as we say, transparent, we can't see past that window currently. We can't see past that 300,000 years because of it. So there is evidence physically all around us in the edge of the observable universe that backs that theory up.
That's good. That's good. I want to move now, if we may, from that Big Bang, the real sense of how physics is contributing to a better understanding of that and so much more, to the practicalities of constitutional change. There's a gear change for you. You're in favour of independence. One of the arguments against independence is the collaboration that you talked about earlier between scientists across the world might well be impeded by, separation. How would you answer that question?
It's a valid concern. Brexit is the prime example right now. Brexit has had a huge impact on UK science. It's causing all sorts of practical issues, from visa issues, like a lot of scientists that have left. We have scientists from our collaboration that left to move to the European Union. You hear that phrase brain drain, like people, very good physicists and scientists that have left this country because they no longer felt welcome post-Brexit, and it was easier to allow them to collaborate and get funding if they still remain members of the European Union. So that's something that, you have to be extremely conscious of. It all depends, I guess, in the context of the agreements that are reached between countries and states, because we also work with the Americans, we work with the Russians, we work with the Chinese. So those barriers can be overcome. Unfortunately, you just have to have the political will to do so, and to make sure that it's not ultimately detrimental to what I would argue is one of the most important industries that exists in one of the most important sectors of society.
What's the general view, if there is such a thing, that you detect in the groves of academia about Brexit? How do people generally feel about Brexit?
Relatively, generally, I would say from my personal experience, overwhelmingly negative. It's putting up barriers between people. It says there's the human element of it. People are being excluded. People physically can't go. People can't come here to do research. We don't have the diversity which you have to have in science. Diversity of thought and diversity of background and people that we require is disappearing because people are not coming here anymore, because it's just not worthwhile for them. And we are losing also opportunities in that, be it funding opportunities or, again, collaborative opportunities, because all the other countries that are members of the European Union, life goes on, they keep working with each other, on they go. Whereas now there has been this sort of jolting framework change whereby we can no longer do the same levels of collaboration. So it's something to be considered from an independence point of view. But as it says, a lot of it is just political will. With Brexit, we've very much gone down the nationalist, we're better than you, we're inward looking, we do everything better, best of British, that kind of thing. Whereas you can still have a positive separation that allows you to say, well, we're still going to work collaboratively. We're going to be outward looking. We're going to be welcoming as a country, and we still want to collaborate with other people in doing that.
But isn't there a risk that an independent, separate Scotland would add another level of separation between between the academic community and the rest of the world? So you'd have Brexit, then you'd have this other thing, in addition, making things even more problematic. Isn't that a possibility?
That is definitely a possibility. And it very much would sit within the context of whether Scotland would then vote to rejoin the European Union, which I would presume it would from obviously polling during the Brexit referendum. But that's not a given, and there are people in Scotland who voted for Brexit. I understand why. So it's just something that has to be considered. Again, you have plenty of countries around the world who are not members of the European Union who may be part of other political unions or cooperation deals with other countries, but we can still do science with them. It's not an absolute end all that you would be isolated. And I certainly don't think Scotland would want to be, considering its proud history of innovation that it has.
Well, it was interesting when I asked Marcus Chown last week much the same question. He said, more or less, I would love to come to Scotland because you guys have got he says you should really ought to have your act together now because this Brexit is a disaster. And he sees nobody around him who actually wants to change that. In other words, people around him are generally happy with Brexit. Well, happy with a small h perhaps, but not hugely discontented, which he finds rather odd, because for him it's deeply disconcerting. As a scientist, he doesn't understand it. He doesn't understand why he would vote for it. He doesn't understand why it might continue. But the opinion polls are fairly clear that the group that favoured Brexit most is riding high, fairly high in the opinion polls. And its main opposition is lagging well behind. So he doesn't see any immediate prospect of change. So therefore he said, well, if independence is an immediate prospect of change, I'm for it. Unlike Anthony Grayling, I'm not sure he would actually campaign for it, but it's an interesting, and both of them seem to feel that a constitutional change in Scotland might lead to an improvement in the rest of the UK, because if you're going to restart something, it's easier to break it down and recombine it. That might apply in physics as well as in constitutional politics. I don't know. I don't really know. What do you plan to do once you have once you're a PhD graduate? What would you like to be doing, Graeme?
Something completely different again. I have a habit of hopping between very strange career choices. So what I'd like to do actually is move to Canada for a while to do my commercial pilot's license. So the commercial pilot's license isn't flying big planes, it's flying small aircraft. And ultimately one day what I would love to do is work with aircraft in a very niche sector called scientific aviation. So using aircraft to do everything from aerial conservation to things like atmospheric research. So sampling a lot of data that goes into these IPCC reports that I'm sure many of your viewers know about, that link into the COPs, they get fed into the COPs and sort of link into all the work that goes in around the climate crisis, is taken from aircraft to fly in certain patterns, measuring the air, measuring CO2 in the atmosphere. There's also an astronomy side to it. We do aurora borealis research up in Finland and aurora australis down in the southern hemisphere, to do basically aviation science from the back of a plane. And I would love to combine the two passions of mine, which is flying and science. And I think that'd be quite an exciting career to pursue.
Have you flown solo, or is that
so I've
something you want to do?
Not flown a powered aircraft solo. I've flown a glider solo, though I did that, I think when I was 17. So it was just before I could drive a car. So I've been flying quite a lot, though. Yeah, I've been flying since I was 13. I did that originally through the cadets, and then I've done it occasionally with some friends, but it is an exceptionally expensive thing to do, and I have been saving every penny since I was 18 to do that. So yeah, it's not like I could own my own private plane. I don't even think I'd want to one day. I'm quite happy just doing it for a job rather than actually owning my own. It's too much money.
One of the sort of interesting experiences I had was in Costa Rica, where we wanted to go from the capital, San Jose, to the Pacific coast. And that meant flying in a very small plane indeed, where not only was our baggage weighed, but we were weighed as passengers to ensure that there was enough power in the system to carry us over I think it was the Sierra Madre or some such thing, mountains. And the actual plane itself was relatively underpowered, which meant that in order to reach a necessary altitude, we had to do this sort of thing, like some sort of spiral roadway up the side of a mountain until we got sufficient altitude to fly across the top of these mountains.
Sounds about right. Yeah. That's it. Also a bit of physics in there. Is you don't want to load any aircraft so that all the weights on one side or all the weights at the back or all the weights forward. So you've got to spread it all out nice and even. Yeah, I never got to fly in small planes in Costa Rica, but I would love to do bush flying out there. I had the chance to visit Costa Rica for 4 days. Like I was working, this was in my old defense job in Florida. And then I could take like what was called local leave. So I flew out to Costa Rica for 4 days. Actually, predominantly to see sloths. I'm a big fan of sloths, the animal, but also as a country as a whole, it's got, I think, 3% of the entire world's biodiversity in that one country. And yeah, I would love to, I think if I was going to retire anywhere, it would be Costa Rica, the land of coffee, chocolate, and bananas as well. Like, what more could you ask for?
Exactly. And no army. It's the only country
no standing army.
And when we were there, I asked, how does it work then? Because Latin America has this shocking reputation for military coups, I mean, all sorts of problems stemming from bad military behavior, poor military behavior. And I thought perhaps there was a connection between the two, but the locals said, no, we just didn't feel it was necessary to have an army, even though they're bordered by, Nicaragua and Guatemala, blah, blah, blah. They all have rather interesting sort of divisions, armed rebellions and all sorts of different guerrilla groups, etc. But they seem to get by. And they did say on one occasion that there was a group who tried to ferment some problem. It may have been Guatemalans, in fact, maybe Nicaraguans. And they holed up in their embassy. And of course, having no army, there was some confusion about how to deal with this situation. And eventually somebody decided to negotiate. And they asked these folks, what is it you particularly want now that you've created all this mayhem? And they said, well, actually, the first thing we'd like is pizza.
Priorities.
Which must be a tribute to the negotiators. Anyway, so the next stage in the negotiation was, if we give you the pizza, would you be prepared to go to the border? And so that we could remove this problem. And they said, sure, if it's the right pizza and you send the bus, we'd be more than happy to decamp and leave you in peace. And to me, that made Costa Rica even more endearing, was the fact that there is no army and the fact that people seem to get by perfectly well without the big defense expenditure. Maybe that's because they don't pose a threat to anyone. I really didn't have enough time to spend there to figure that out. But I found it intriguing and an interesting place altogether. I'd like to come back, because we don't have much time. We've got about 8 minutes, if you don't mind, to talk about COP26. And I'm going to ask you to, if you could, evaluate the progress or lack of it so far, because I gather that the big players, such as the national leaders, have all left now. What's your assessment of where we are just now with COP26? Has it been a success, or are you disappointed?
I mean, the problem is I'm in the stage where I feel I was always set up for disappointment. It's, as many people in Glasgow say, and I completely agree, it's just a talking shop for predominantly the wealthy countries, wealthy people, to conserve that power and conserve that wealth. I think a lot of people understand that what needs to be done is going to have a massive impact on our lives. The amount of radical change which is required to avert the crisis that is here and now for many countries, and is coming for countries like Scotland soon. But in order to do that, it requires the people who have all the money and who have all the power to give that up and redistribute it. And I just don't see it happening. We've had previous COPs, just like we'll have this COP, with countries in the global south, with prime ministers and presidents who are politicians. A lot of people say, oh, it's the politicians don't care, but there are people there who are having to represent their country that is physically going underwater, is losing large areas of land, is millions of their citizens are dying, and pleading with our leaders in the north and the rich Western nations to have some humanity. And I think all you have to do is look at the way these leaders treat their own people, let alone people in the global south, to give you an idea of how they're going to approach this problem, because it is just going to be fanfare and look how great this is. And as we hear from the young activists, as we hear from activists who've been on the picket lines, who've been protesting for decades, but people say it now, we need action. We don't need rhetoric, because it's too late. We've run out of time. And the scientists have said it. We saw that from the IPCC report. And as most people know, scientists, the most reserved, cautious people, when they said code red for humanity, that really hammered home the message, certainly from the scientific community. We have to do something right now. And I don't think it's going to come from COP. I think it's going to come from people on the ground who are just going to get so fed up. And I just hope enough people try and mobilize now, even when they're in comfortable positions like me, to rally around people who are struggling now before it becomes too late, before you end up in that position yourself. I'd rather we are proactive about it rather than being forced into it last minute when we see even greater food shortages, even higher fuel prices. That's my fairly negative take on that side. Is positive from everything outside of COP, but negative from everything inside of COP, I think.
What's actually been agreed, is anything been agreed? All these leaders have left now. My understanding is that the only progress has been some commitment to reducing methane.
And there was some commitment to, I think 100 countries signed up to stopping deforestation, I believe by 2030. I think that's a prime example. That's too late. And again, I just don't see, it's just putting targets down the line that you can just miss and say, oh, well, we didn't reach the targets. The Scottish government has missed its own targets as well. And that's the issue with targets, is they're always set far down the line and no one really keeps track of them, and then they're missed. And by that point, it is too late. And you can only say it's too late so many times before it really hits home. So
we don't have a lot of time left, Graeme, but I would very much like to hear from you what impact there is going to be in Scotland because of the issues that you've just outlined. What would you expect to see happen in Scotland in particular?
A prime example is people have complained about gas prices at the moment and food prices at the moment. And don't get me wrong, there will be temporary reprieves. The food prices will go up and down, and gas prices will probably come back down at some point. But I think if you look at the overall trends of these things, if anyone thinks that gas prices are going to be cheaper in 10 years' time, or food prices are going to be cheaper in 10 years' time, I think they're living on another planet. So day-to-day living is going to become more expensive. We've seen mass flooding in Scotland last week in Glasgow, just last week, and they are becoming more and more frequent, these events. And, I appreciate people get frustrated at some of these protesters sitting on roads and inconveniencing people. And I hope that they don't do it in areas and communities that are vulnerable, and particularly working class areas. But I'd ask people to remember that that's not as inconvenient as your road getting washed away. It's not as inconvenient as ambulances not being able to leave a hospital, like they couldn't leave Gartnable last week because of the flooding. So there's going to be a lot more flooding, and it's going to impact the poorest people in Scotland. Look at the Glasgow flood maps. It's all the poorest areas that are going to get hit with it first. These people are going to be underwater, turfed out their homes. So there's going to be more extreme weather impacts. There's going to be food shortages. And as I says, I think it's about being proactive rather than being last minute scrambling to try and save ourselves. Because, I don't want to make it all doom and gloom. There are ways to tackle this. There are ways to improve. But Scotland is definitely going to be at the forefront of it in a few decades' time. And we're already starting to see the tremors now.
People watching and listening tonight, what would you like them to do right now?
Support the people around you who are asking for help in any capacity, and try to understand that try to think about that if you're in my position, because of my education, I'm fairly middle class these days. I know that I will be in that position in 10 years' time. And even if you think of it from a selfish point of view, which I don't think is a bad thing, think about where you might be in 10, 20 years' time. Obviously, people who have kids, think about their children, where they're going to be, because they're going to be in that position. And just get involved. If you've got time and capacity to read up on these things, learn about how poverty, learn about fuel prices, learn about the fact you're in insecure work, learn about the fact that the people in power, that it is all connected. All of these things have not come about by coincidence. And understand that we have to fight for a systematic change. You hear the phrase system change, not climate change, and it's true. We need a fundamental systematic change of the way society is structured in a way that benefits people who are in the working class areas of Glasgow and on the breadline at the moment, so that we don't have an increase of billionaires during pandemics, for example. We don't have rich people getting richer and making money off the back of destroying our planet, which is what's happening right now in front of our eyes.
Yeah, I mean, I think lots and lots of people will agree with you, and I hope they'll take your advice, because the alternative to not taking your advice is to assume that you've been disempowered. You don't have anything in your disposal that you can actually do. And I do feel that it's hugely important. I sometimes talk about PMA, a positive mental attitude, but I think if you have that, then listening to what you're saying and trying to use some of that knowledge and that background is empowering in itself. We're almost out of time, folks. I would like you, please, if those of you who are watching and listening, to know that the Scotonomics show follows this one. So don't switch off when we're through. Please stay on the line and watch Scotonomics. You'll find it vastly enjoyable, and you'll see on the screen the details of the Saturday march and rally. And as Graeme so eloquently pointed out, this is one of your opportunities to make your voice heard. So I would strongly encourage you to take advantage of that. Turn out for the rally, join whichever group is appropriate to you, and say your piece, and make sure that people hear you saying what you're saying. Graeme, thanks very much. If you could hold on for a second once we're through, I'd be grateful. I just want to make a few concluding remarks, if I may. First and foremost is obviously to thank Graeme for joining us tonight. And also a big thank you to all of you, because I know you have busy lives, but I hope you found the show as enjoyable and as educational as I have. I've learned a lot tonight. As ever, we have more formidable guests coming up for future shows, and you can see the full details on the What's On Guide at www.whatsonguide.scot. We're back next week at the same time with another special guest, Julian Caldecott. Julian describes himself as an ecologist on a mission. So there's a neat tie-in between the very important comments that Graeme has given us tonight, and Julian will be adding a further dimension to that. And do look out for my Constitution column, as I always say, in the Sunday National. Thank you again, and a good night. Join us next Wednesday. And remember, it's been a great day for British democracy, where corruption is now official. To all of you, thanks for joining us. Please stay safe and take care. Good night.